Okay, polynomial and rational inequalities. You actually already graphed these things before they were on your test, but they had equal signs in there. So when we start putting inequalities in, what's the only difference between that and the ones that have the equal signs in them?
They're shaded.
There's shading, and there could be
dotted lines.
Dotted lines. All right. So is this one going to be dotted lines or solid?
Solid.
Solid. How do we know?
Because there's a solid line.
And equal to.
Yep. There's a bar underneath my greater than sign. Okay. So then we just have to graph it like normal. So where will the zeros be?
-1 and positive. No, -3.
Positive
1.
Mm-hmm.
-3.
Okay. Now, if I were to multiply all of this out, what would be my highest power?
Cubed.
Okay. So my end behavior is going to do what?
It's going to be like a cacti.
Okay.
Okay.
All right. And then what's going to happen at -3? Is it going to cross it or bounce?
It's going to cut through.
It's going to cross through it. How about at 1? Will it cross through it or bounce? Bounce. Okay. Now, when you're picking your point, you want to be really careful because remember, these are just sketches, so they don't do exactly what we thought that. Like this may go up higher, it may actually come down lower. We're not real sure. They were just sketches for us. But one thing that we do know is that they're functions. So I'm not going to have more than one point on my graph above or below a point that I know is there. Okay. So if I pick something that's 1, anything else, I know that it's definitely going to be above or below because I can only have one y value for my x value.
So let's choose 1, 2.
Okay, so if we go 1, 2, definitely above my graph. All right, so this would be my y, and then this is my x. All right, so we want to see how that's going to compare. So if I go 1, 2, I'm going to have 2 is less than or equal to, now if I plug 1 in here, I'm going to get 4 times 0 squared. So I'll get 0 is greater than or equal to 2. True? No. So I have to shade below this graph.
Well, this week we're doing with the other guys when I was in here.
Yep.
So if it's no, you have to shade the opposite.
Mm-hmm. Ooh. Bad shade job, but that's what I'm going to get for that one. So now if I were to plug that into the graphing calculator, all right, it's going to look like that. That's pretty much what I had. The only difference is this one actually came up a little bit higher than that one did. All right, but other than that, it looks pretty much the same. Okay, what do I do with something like this then?
What do we want to factorize?
A dotted line.
It's going to be dotted.
And isn't 0 going to be its?
I don't want to just start plugging points in. That's a lot of work.
Subtract x both sides.
Get everything onto one side. Sounds good. So x to the 4th minus x is greater than 0.
So
What can I do with this?
you can take out an x.
Leaving me behind with x cubed minus 1. That factors. That's the difference of 2 cubes.
It would be minus plus plus.
Minus plus plus x 1 x squared 1 x. All right, now. So what's going to make this 0?
0.
What's going to make this 0?
1.
What will make this 0?
Let's put it in.
Do you just solve it for x?
Well, it's a difference of 2 cubes. The part that has the quadratic in it, what's that always give us when we put it in the quadratic formula? It doesn't factor.
So it's going to give us some sort of imaginary number.
Imaginaries. So we don't even have to worry about those. Right, but these two I do. So I'm going to have a 0 at 0. I'm going to have a 0 at 1. Now, how many times did I get each one of those as a solution?
1.
Once. Okay, so we're going to end up getting, that means it's going to cross through them. Now, if I multiplied all of this, well, actually, this was already multiplied out. If we look back here at the original, highest power.
4th.
So what's that mean about end behavior?
It's going to be
For you.
Touchdown.
It's going to look like for you.
It's going to look like, yes, because it's an even number.
Oh.
So it's going to be like touchdown, like a parabola. Right? It's got to cross this one and it's got to cross that one. Now, what else do you know about x to the fourth graphs? What do they typically look like?
They are wider, like they're pudgy.
Okay, they end up being a little bit wider than your normal parabola. What else do they usually do?
But they usually make a W.
Or an M, right? Depending on which way they're facing. So this one would look kind of like a W. Now, I've done this one before, so I got a pretty good idea what this thing's going to look like. My guess is it's going to come down there, cut through that, and do something like that. Now we have to decide whether I'm going to shade inside my W or outside of it. So I need to pick a point that's definitely one or the other.
No.
Now let's pick something. I knew that this point has to be here and this point has to be there. So I want to pick something above or below one of those.
0, 1 or like 0.
Okay, 0, 1 is definitely below my graph. So if I plug that in here so that this is my Y, right?
No,
0, 1's
1. That's 0. Negative
0, 1. Okay, that's definitely inside my graph then. Right, so then we'll go 0 to the fourth minus 0 is greater than 1, because this would be my Y, right? So is 0 greater than 1?
No.
No, so I'm going to have to shade on the outside of my graph.
Okay, why is that W shape at the bottom?
What's that?
Why is it that like pinched shape at the bottom then?
Pinched shape.
Why is it a W? Is what you're saying.
Yeah.
Most x to the fourth graphs are going to end up being some sort of W shape, but I mean, if you just made it cut through there like a parabola and go through, that's okay for now too.
Yeah, I was trying to say
Right.
because like,
They don't have to be perfect. The only reason that I knew that it was going to do something like it's going to have a little bend to it, because I've done this one before. All right, so now if we take a look at this thing on the graphing calculator, see it kind of has that little bend to it there. But what it does do is it cuts through 0 and it cuts through 1, and it's shaded on the outside just like we said.
Seems pretty easy.
Yeah, you've basically already done these before. All right, now this one, what's a little bit different about this one? What's this one got that the other ones didn't?
Asymptotes.
It's got asymptotes. What kind?
It would have
Vertical.
Where are they going to be?
At 1.
Nope.
0, 2,
Nope. 2
White.
and negative 2.
and negative 2, because that's where my bottom would be 0.
So it's the horizontal one.
The horizontal asymptote is going to be not at 1,
At 0.
at 0, because I have a higher power at the bottom than the top. Alright, so when I go to graph this thing, I have a horizontal one at 0. I'm going to have a vertical one at 2.
This is the exact same lesson you gave. Okay.
What do you think I do all day, Jake? You think I make up one special for you every day?
Yeah.
Yeah.
Yeah, right. You wouldn't do that.
I remember this.
Okay, so all right. So that's what I've got so far. So now what do we usually do before they were this type?
Test form.
Oh, one thing that we should have looked at up here before, you guys told me at the beginning, this thing should have been dotted. Okay, now is this one going to be solid or dotted?
Solid.
So everything's going to be solid for this one. All right, so when I go to graph this one, let's pick some points. What do you want to try?
0, no. 1, no, 0, 1.
We'll just pick some x's so that we can get the actual graph drawn first. 3.
3.
Okay, so 3 is going to be outside here, so we'll tie f of 3. That's going to get me 3 minus 1 over 9 minus 4. 2 over 5. 2/5. Something that looks like that. All right, negative 3. If I do that, I'm going to get negative 3 minus 1 over 9 minus 4. So I'm going to get negative 4 over 5, so negative 5/4. That's going to put me down here, 4/5. I have a rare form of dyslexia where I flip numbers upside down.
Let's do 0.
It's called reciprolexia. I just made that up.
Okay.
All right, now I also have to test in between here. So we're going to go f of 0. So what will that give me? You can do that one without even trying.
It's negative 1 over 4.
Negative 1 over negative 4.
So it's 4.
So 1/4.
I mean, it is greater than 0.
Okay, so that's bigger than 0. What if I put in 1?
It's gonna be 0 over
Something. What's that get me?
0.
0. What if I plug in negative 1?
It's gonna be negative 2 for
1 minus 4. So I'm going to get positive 2/3. What's this one doing?
It looks like it's
going up.
like a cactus thing.
Yep. Let's do one of these. Okay, now we have to decide, are we shading above or below this graph?
Let's test some points.
So we want to pick something that's definitely above or below. Now it doesn't matter whether I'm above this line or below this line or above this line or below this line or above this line or above or below this line. All those sections are going to do the exact same thing, so you just have to pick one.
2, 2. No. Yes. All right, let's go 0, 1. 0, 2.
Okay, 0, 2. So that's definitely above one of my lines. So if I plug that in here, 0 in for x, 2 in for y. So if I do that, I'm going to get positive 1/4 is greater than 2. Is that true?
No.
No. So where am I shading?
Below all of those.
Everything has to get shaded below. So I have to go below this line. We have to go below this one in that section. And then I also have to go below this one in that section.
Would you also shade that?
So I didn't get right up in there, but this is going to go right up in there, right up in here. Okay, so if we were to look at what that looks like on a graphing calculator, it'll look a lot like what we have.
Is that the last one?
I had one more, but it'll be on mine.
Can I get one?
The homework.
No, I have to go.
Okay, last one here. So for this one, where will I have a vertical asymptote?
Yes, negative 2.
Okay. How about a horizontal asymptote? I was wrong. I thought that it couldn't be more annoying, but it actually is. Micah? At 4, because it's my leading coefficients ratio, so I'm going to have a horizontal asymptote at 4. Now, careful. Let's take a look at this one again. All right, what's different about this problem as compared to all of the other ones?
It's not equal to 0, you have to subtract 3.
Okay, so we want to make this thing so that it's equal to 0, so I want to subtract 3 from both sides. So I have 4x plus 5 over x plus 2 minus 3 over 1. That's greater than or equal to 0. Now this still doesn't look like the ones that we've done before because we just had one fraction. So I need a common denominator.
X plus 2.
Mr. Pepko, please call 5202. Mr. Pepko.
So this one didn't change, but this one did. So what's my new top going to be?
3 times 4x plus... No, x plus 2.
3 times x plus 2.
4,
Now I can distribute this negative 3 through here and put them together. So I'll get a 4x plus 5 minus 3x minus 6 over the x plus 2. So my actual equation,
an x minus 1?
So it'd be x minus 1 over x plus 2.
x minus 1 over x plus 2. And that's still going to be greater than or equal to 0. So now, all right, where's my vertical asymptote? We were right. It's still at negative 2. Now, horizontal asymptote, where's that going to be?
1.
1. So that did change things a little bit. So it's going to be at 1. But this graph actually got a little bit easier to graph than it probably looked like before. So I'm going to have a vertical asymptote at negative 2, a horizontal asymptote at 1. Right? So we have to decide what's happening with my shapes. So I want to graph this. And it doesn't really matter what we plug them into. This is probably my easiest thing. So if I plug a 0 in here, I'm going to get negative 1 over positive 2. Negative 1 over positive 2 is negative 1/2. So I'm going to get this. Right? If I plug in a 3, I'm going to get 3 minus 1, which is 2, over 3 plus 2, which is 5. I'm going to get 2/5. Wait, I could be wrong. What happened here? Oh yeah, -3. So I'm going to get a -4 over a -1, which is a +4. Better. All right, so I get -3, +1, 2, 3, 4. So it's up here. This one's going to do that. So now I have to decide where am I going to shade.
Let's choose, I don't know, 0, -2.
Okay, definitely below my graph. So if I plug 0, -2 into this thing, I get 0 minus 1 over 0 plus 2 is greater than or equal to. This would be my y, so this would be -2. Is -1/2 greater than or equal to -2?
Yes.
It actually is, because this one is less negative than that one. So I'm shading below here. So I'm going to have to shade below this line. And I'm going to have to shade below this line.
I'm thinking about asking the same question somebody else did in the other recount.
Like that. All right, we double check to make sure that that's what my graph's really supposed to look like on the graphic calculator. It is. It looks pretty much like what we've got. All right, so we really haven't changed that much from what you guys just took on the test. You guys are still graphing those weird graphs, some with asymptotes, some with not, where you're just interested in their zeros and you're working with their end behavior. You're doing both of those things, but then you have to test some points and decide whether you're shading above them or below them.
All right.
Easy enough?
Yeah.
Okay, homework's there, page 217, 5 through 8, and 19 through 47 odd.